Hi everyone. So I think we can start our class for today. Can you see my screen?
Yeah.
Thank you, Noel. So last week we already finished chapter 4, which is 4B or 4.2, network operation, background operation, and server for mobile. So today we will start with chapter 5. Okay. And then I already posted quiz 4 in our GC and I already informed you guys in the group. Okay, so you may answer the quiz because we already finished that chapter. So here, as you can see, chapter 5, location-based service. I think you can guess what is this chapter about. Location. Okay, location. As you can see, we have this image here. Okay, your location. So before we start our lecture, actually I found a YouTube video which can explain this chapter. So before we proceed with this lecture or before I start, I will share with you a link. So you may go to this link and watch the video. This is like an introduction. What is the IES? Sorry, LBS. Mm, yeah. So this one is around 6 minutes. So yeah, go to this link and watch this video. So this one is around 7 minutes. So we will start or we will continue around 4:46 or 47. Okay, so watch the video first.
G'day, I'm Chris Muir. Welcome to this introductory video covering the concepts of location-based services and how they relate to Oracle Mobile Cloud Service. Google Maps and similar services are, you'd agree, ubiquitous in mobile applications today. Since its introduction way back in 2005, we have come to depend on Google Maps and its mapping functions. But it's no longer 2005. And in 2016, with Oracle Mobile Cloud Services location-based services, you can lift your mobile applications from just showing, well, maps to delivering unique business value based on the mobile user's locality. So imagine this. Imagine, for example, our mobile sales force is on the road using our great sales application to visit customers. Now, as you'd appreciate, in any modern city, they're often gridlocked, so it takes a lot of time to get around. Unfortunately, a customer has cancelled a meeting just as our sales team arrives. And rather than our team wasting their time coming back to headquarters, they'd like to visit any customers, say within 2 kilometres, to make up for the cancelled meeting. But there's no point visiting any customer who just, say, purchased items from us. Rather, our sales team would be best to target customers they have visited, or haven't visited, I should say, for 6 months, say, who are more likely ready to purchase from us again. This is the sort of advanced capability MCS can provide. The ability for a mobile app not just to serve up the location of our sales member or customer on a map, but to extend the app to query back customers based on their proximity and actual real business data on, say, in this example, sales opportunities in the user's proximity to. Okay, let's imagine this scenario instead. Say doctors are at a public hospital and they are equipped with digital tablets to allow them to efficiently work with digital paper records while in the hospital grounds. Hallelujah! Finally the days of paper-based patient forms are gone. However, as there is a risk of the tablets being stolen, and the hospital policy is that patient records may only be accessed while on the hospital grounds, we can extend our mobile application to intelligently know about the hospital's boundaries, setting up a so-called virtual geofence, such that when the device leaves the hospital grounds, the app automatically disables itself, protecting the patient records from inappropriate use. Let's imagine one last final scenario. Every day the London Natural History Museum attracts thousands of visitors, enjoying I remember the dinosaur displays and how great they were, amongst many other exhibits. Within the confines of the museum, without a GPS signal, imagine using localized beacons that talk to the museum visitors' mobile devices, communicating with the museum app that notes the visitor's location and, say, pops up relevant information about the Raptor display or any other display that the visitor is currently viewing. This means the museum can remove many of the old signs and replace them with modern digital experiences, utilising the visitor's very powerful own mobile devices. And we can even take this a step further and ask our visitors if they, like Raptors because they've been looking at that display for a while, would they like, say, a 10% discount on all Raptor toys when they visit the museum shop. Hopefully you can see with Oracle Mobile Cloud Services location-based services, we can go far beyond just simply showing a map with a pin based on the mobile user's latitude and longitude or the location of some local shop. We can extend our apps to provide many useful services based on the mobile user's location, mashing that up with all sorts of really useful business data. This is really the next generation of enterprise mobile services at our employees' fingertips. It really is time to move beyond Google Maps. Okay, so let's distill these location-based services into the core concepts, what we like to refer to as locality, proximity, and vicinity. A proximity service provides contextual information of places that surround a mobile user's location within a set distance, such as this travelling salesman example we talked about earlier, where we not just reveal customers in the salesman proximity, but we mashed in business data into the query to work out customers that the salesman hadn't recently visited. Conversely, a vicinity service, such as the hospital patient record example we spoke about, is one that may be based around a geofence, for example, where we target the mobile user with personalized messages or services as they enter and exit that geofence. Finally, like the Natural History Museum example we spoke about, a variation on the theme of vicinity services is the use of beacons. When the mobile user enters the range of the beacon, we can also provide contextual-based information or services. Now this creates a nice point to talk about beacons in a little bit more detail because not everyone knows about them. While GPS is a great feature of mobile devices, it does have some limitations. Sometimes it can be inaccurate as the mobile device is having trouble obtaining a signal from the satellites. Or even if it is accurate, thanks to the limitations put on GPS by the military, it may not have the level of accuracy that you require for your app. And of course, GPS is mostly not available indoors either. So wouldn't it be great if we could use some sort of, localized GPS? Say a set of devices that tell you, or more specifically your mobile device or apps, where you are without relying on GPS. And indeed in the mobile industry, such devices exist. They're called beacons, namely iBeacons or OldBeacons and Eddistones, which you can manually position and configure mobile apps to listen for across low energy Bluetooth. And indeed, here's an example I have of a beacon called a RadBeacon Dot that supports all three beacon technologies. You can easily purchase these yourself. Great, so that's the introductory concepts of location-based services out of the way. Stick with us in the next videos where we're going to investigate how you use location-based services in MCS, including the server-side and the client-side SDKs.
Yeah, so the link to the video that we watched just now is like an introduction to the LBS or location based service. So if you watch the video, basically for LBS location based service is not only for mapping the map, okay? So they can have other benefit, other function that apply this technology, location-based service. For example, there's one game last time. It's known as Pokemon Go, if I'm not mistaken. So they use this technology. Okay, I if I'm not mistaken, because I didn't really play that Pokemon Go, but this Pokemon Go is a game, but it is banned in Malaysia for security issue. Okay, so this game give access to the player for the map and then the geographical location. Okay, so that's why it is banned in Malaysia. So basically, that's the use of LBS, location based service. So in this chapter, we will see this is the objective for this chapter. Okay, basically it's all about this service, location based service, or how to apply into your application, or how to connect it with the IoT, Internet of Things. So objective one, explain this LBS, location based service. Second is understand and explain the concept of Google Play Service Location API. We will see what is the relationship between this service, Google Play Service Location API, with the LBS. So location-based service, okay, it is actually a service that provide a location to the user. Location here can be the accurate, okay, your location, which is accurate location, or approximately. Okay, so there's a type of this service letter. So mobile user take their device with them everywhere. So location awareness can be used to offer contextual experience. That means location awareness. Why we should, or what's the purpose? Okay, we use this location-based service LPS. And then Android, yes, Android, they use Google Play Service Location API. So this Google Play Service is actually for the security and reliability of our application that we have in our Android. So for Android, they use this Google Play Service. So here they have this function, location API. That means they provide the device, they provide the phone with this function, location. Okay, so here we have location strategies. So the first method is, two ways to obtain a user location. We have two methods. The first one is GPS. Okay, GPS stands for Global Positioning System. Next, or N, Wi-Fi. Okay, GPS and Wi-Fi or cell tower. Cell tower is a tower actually that used for communication. They have like an antenna, okay, for communication between the device. So let me go, yeah, dispatch actually. So the first one is GPS. Okay, so for the GPS, the accuracy is quite high. Okay, quite high, but the speed is low. Speed here can refer to speed here can refer to the response times. Okay, so it is the speed for GPS is slow. Okay, it's quite slow for them to return to you where's your location or what is the location. And then power consumption, battery consumption high. And then the environment we can use for it is outdoor. Next is Wi-Fi or cell tower. Cell tower is the tower just now that I said. It's like they have like an antenna. Antenna, is it? Yeah, they have like an antenna. So Wi-Fi or cell towers, so the accuracy is low. That means it is not as accurate as your GPS. But the speed, as you can see, there's a difference here. High accuracy with slow speed, but or low accuracy with high speed. Okay, so that's the difference. You want high speed, but it will be low in accuracy. If you want to have slow speed, it will be accuracy. So the power consumption also low, and then it's indoor or outdoor. Okay, so there are two methods to obtain the location of the user. Okay, using GPS or Wi-Fi or cell towers. Okay, so usually we the user is the GPS, your location here. So here is the concern, actually, the battery drain. If you refer to the page 6 just now, power consumption. Okay, high speed with low power consumption. High power consumption with low with slow speed. Okay, so location, gathering, and battery drain are affected by this aspect. Like I said, the concern is the battery drain. First, of course, the accuracy. How accurate your location. Okay, next is frequency, how frequent, and then the latency. Latency here can refer to the delay of your speed. Okay, like I said, delay of your speed, how fast or how slow you can get the result. Result here is in the location. Okay, battery drain, power consumption, accuracy, frequency, and latency. So let's go to the first one, which is accuracy. Okay, accuracy, I think you know what is accuracy from the word accurate. Okay, how accurate is your location? So accuracy, the precision of the location data. Yeah, they use the term precision. However, accurate is not precise, precise is not accurate. But yes, accuracy here, they use precision. Okay, precision, how accurate is your data? So the higher the accuracy, the higher the battery drain. Okay, so this is the theory that they have. If you want to have higher accuracy, they will use your battery. Higher accuracy, higher battery drain. Yeah, I will go to this patch because we can see all of this comparison here. Okay, so the priority, high accuracy. Okay, high accuracy. So here is the constant, priority, high accuracy. That means this is how you want to implement in your code. Okay, priority, high accuracy. So we know that it is high accuracy. So the description, most accurate location data enable the GPS, Wi-Fi, and cell. Okay, so you have this, I think most of the phone, the current technology, they have this function, enable GPS. I mean, they have this location function, the location or the GPS. Next is balance power. So the constants here or the command here is priority, balance power, accuracy. So provide accurate location data so they can use either GPS, may use the GPS, typically use the Wi-Fi and the cell. So low power, priority, low power, okay? And then relies on cell towers mostly. Cell tower is the tower that I mentioned just now. Usually at the cell tower or at the tower there, they have like an antenna for the provider. Okay, so they will like place the antenna at the tower. And then no power. So priority, no power, receive location data from other apps. That means they merge, it's not much. The link to get the data. Your location is from the other apps. Okay, so this is the command. So from this command, actually, we can know what is the priority. For example, here, priority, high accuracy. So that we, so from this command, we know that this is high accuracy. Next is balance power accuracy. And then low power and no power. Okay, so yeah, that's the constants for the priority for the accuracy. So remember, accuracy is how accurate is your location. Okay, sometimes when you turn on your location function there, they won't return to you your exact location. Of course, they will be different. I think around meter. They won't give you exact location, but there will be a different actually in meters. But sometimes we as the user, we don't really notice because it's only in meter. So next type of priority. Okay, so here is from the previous slide just now. Okay, type of priority based on the priority. First, we have this one, balance power priority. Okay, so city block 100 meter. Like I said, there's a difference in accuracy. It's not the exact location. Okay, let's say you want to wait for example, you want to book for a Grab. Okay, they will ask you for your location, but of course you cannot notice what is the difference because for example, this one, it is only within 100 meter. Okay, so balance power priority, city blocks, the precision, the accuracy, this now the accuracy is around 100 meter. So hardware, Wi-Fi or cell tower, the power is less. Okay, because it's only 100 meter accurate. That means it is within 100 meter. And then next is high accuracy. High accuracy, most precise location possible. Okay, most precise, not the exact location. So most precise location possible. So you use GPS, geographical positioning system, and then the power is of course high. Like I said, high accuracy, high power. Global positioning system. So next is low power. Low power, city level. This one is it's not that accurate because it's around 10 km. City level 10 km. So here they are using the same with the balance power priority. They're using Wi-Fi or cell tower. And of course, the power is less. Okay. Totally different with the second one. This one is high, this one is less. Because this one is almost accurate. This one is around 10 kilometer. Next is no power. So of course, no power. They get the location, no power or no location. So here they get receive location from other apps that provide the data to your location. Okay, hardware use none, power very minimum. That means less than this low power or even this balance power priority. This one is the lowest one, very minimum. Okay, so next we are going to see frequency. Okay, frequency, we have this function, set interval and set fastest interval. Okay, so interval to compute location data. Interval to compute the location data. The gap. So use the largest possible value for background location and then use small value for foreground. Okay, so you have these two process, which is background location and foreground location. So you're going to see later what's background location and what's foreground location. Okay, so next is this function set fastest interval. Interval to compute location data for other apps. Okay, if you remember in our previous slide, we can get data from other application. We can get the location. Yeah, we can get the location from other app. So here, to compute location data for other apps. That means you want to supply your data. Data here is referring to your location. You want to supply this data to the other apps. So basically you have these two functions, set interval and then set fastest interval. Okay, so still under frequency, so interval of update could be achieved. Okay, first method is set interval. Okay, set interval sets the rate in ms, millisecond. This is the default unit. If you have other value, then if you want to use any other unit other than ms, you need to do the conversion in your code. So here the default unit is the ms, set interval. So speed of update may vary, faster, slower, or no update at all. Okay, and then set fastest interval. Set fastest interval is this one just now. Okay, compute location. You provide your location, the data to other application. So set the fastest rate or the upper limit in ms must be set to prevent UI flicker or data overflow. The UI flicker is like delay. It's like delay or the data overflow. Next is we have set priority. Set priority to the request. Okay, which one should they process first? Which one should they process last? Based on the priority request. Okay, so we have three here: interval, fastest interval, and then the priority. So this is the example. Okay, create location request. So location request, create and apply. So interval is 10,000 ms. Okay, so 10,000 ms. So here 1,000 milliseconds is equal to 1 second. Like I said, the default unit is ms. Okay, so maybe in the next example, you can see how they do the conversion from other unit to other unit. Sorry, from other unit to ms. This one is the fastest interval, 5,000 ms. Okay, fastest interval. They want to provide your data to other application. Because if you notice, when you install or download your application, sometimes they will ask permission. This one in only for first time installation. They will ask permission to access your location. Okay, together with the permission to access your contacts, your calendar, or your data. So they will also request to access your location. Okay, other apps wants to use the location. And then the priority here. Okay, priority, high accuracy. High priority, high accuracy, you may refer to the previous slide just now. Priority, high accuracy, okay? The most accurate location. The most accurate location, of course, the speed will be high, but the power will be high too. Wait. Just now. Yeah, most accurate location. There's one slide. This one. High accuracy, priority, high accuracy, most accurate location that enable the GPS, Wi-Fi, and the cell. This one, priority, high accuracy. So here you have this interval, fastest interval, and then the priority. So next we have latency. As you can see here, delays location delivery. Like I said just now, latency is like a delay. Delay for us, delay for the application to return or to return the data, the location. So here latency, the delay. Latency is the delay to deliver the data. So here we have this function, set maximum wait time. Okay, what's the maximum waiting time? Delay location delivery. So set a value several times larger than the set interval. Okay, set interval is from the previous function just now. So here we are going to use this latency. The delay for us to get the data. The delay for the apps to return the location. Data here is referring to the location for this chapter. Okay, so here an example, create location request. This is the same actually with the previous example, but they add this one here, this part. Okay, so just now interval same in MS, fastest interval is also in MS. So here maximum waiting time. Okay, like I said, if the unit is not in MS, you need to do your own conversion. So here it is in minutes, so they need to times with 60. Okay, so priority, this one is the priority just now. So this one is the latency. Okay, latency, they add here maximum wait time. This is the value. So here is the question. So I already explained what's the basic of LBS, location-based service. So location-based service is a service that use the geographic data, that use your location information. So I already also explained the accuracy, frequency, and then the latency. So I have a question. As usual, we are going to do this question. So identify a location model, accuracy, frequency, and latency that is suitable for this use case. So a mapping app. So the first one here, even second, it's name. Third is Kelvin chart. First one here is So I give you around 5 minutes to find the answer for this one. .5 minutes, so I think it will be around 5 to 12 minutes for you to return the answer for me. It's already 5:12 p.m. I only received 2 answers. 3, accuracy. Oh. Okay, this one is B. Accuracy location. C is frequency. Okay, so the first one here is the accuracy. Okay, mapping app. Mapping app is West. West is it the what's the app? There's one. I think it's West. It is a mapping app. So yes, we need to use this model from this question here, accuracy. Okay, so it is important for mapping app. For example, the one I mentioned just now is the West, if I'm not mistaken. Okay, so they use a real time. That means they return to you with almost accurate location. Almost accurate location, precise location. So this one is correct, accuracy. Next is weather app. Weather app is accuracy. Why you say weather app is accuracy? Why weather apps is accuracy? Then so what accuracy is the now accuracy precision, yeah, precision. It's not precision. And then frequency interval to compute location. And then the other one is latency, is the delay to receive the data. So here, weather app accuracy, I don't think this is accuracy. Other than accuracy, can anyone suggest me other answer? I don't think accuracy to have to fetch new data, oh, new weather. I think, yeah, should be frequency because they need to update the data or update the weather frequently. Okay, I don't think it is accuracy. So it should be a frequency actually. Same with C. C is frequency. So B is frequency, okay? Not accuracy. So C, a retailer app that notify user who are within proximity to a retail store. Do you think this is frequency? They want to notify the user if they are around that area or around that store. Do you think this is frequency? Yes, it should be accuracy. Why accuracy? Because you go back to the slide just now, accuracy is the precise, okay? The location, not the exact location, but it is precise. That means it is within that area. So this one should be accuracy, not frequency. The last one here is fitness app that can track user activity. User activity, fitness app. accurate activity. Do you think this is accuracy? Accuracy is the location, precise, precise location. So for fitness app, do you think it is accuracy? Daniel, do you think this is accuracy, Daniel? For fitness app, does fitness app track location? Yes, sometimes they do track your location. For example, your running activity, they will track your location. Yeah, my apps that, yeah, they track. Yeah, track how far the user jog, but not the exact location. But this one also, we can say accuracy. Wait. We can say accuracy. Why? Because for the app, okay, they can track your location. Yes, they can track your, they can track your location. This one can consider as accuracy too. Frequency. Frequency. I think this one I have to answer. Why accuracy? Let me explain. Why accuracy? If you have any fitness app, for example, if you go for a walk, they can capture what or where did you go for your walk, or how long, what's the distance. That one is the accuracy. Frequency is they keep on updating your, for example, how many kilometers, how many kilometers did you already walk. Frequency is possible also, yes, because they capture your data, they update the data. Frequency, frequency and the accuracy. Yes, I'll keep my answer, frequency and accuracy. Okay, so for D, it is accuracy or frequency. Does fitness app latency? Latency is for the delay in the data that we use. For example, the delay in data that I receive. What are the example of latency? Is there any example here? Several larger delays, location, deliver. Data. We cannot use this one for West. Cannot. What? The latency application. Wait, let me find first. How latency is used. In X. Networking. Actually, latency. Latency is how does latency is used? Latency is it's not a process, but latency is if we get, I don't think that anyone network speed bandwidth. If you want to say you want to apply the latency in your application, I don't think people will go with high latency. Latency is a concept where it is a delay that you deliver your data related to the bandwidth. Okay, so I don't think there's any application or anything that you can apply with high latency. Latency here is a concept or a model actually. 。 。 。 。 。 。 。 . 。 。 . 。 。 . 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。 . Uh, 。 . Example of latency, you mean the application of latency? Because if you want to use the location, right, they will aim for location low latency. Low latency, that means they should receive high result or high data, high speed of data. Yeah, high speed of data. Latency, I don't think there's any application of latency. Just remember, latency is a delay that delay to receive your data that related to the bandwidth. Okay, people will go for low latency. That's mean high speed. High speed is low latency. Okay, Yin, I also cannot answer your question. That's the concept. Okay, case closed. I cannot answer your question either. So that's the question for the first part, accuracy, frequency, and latency. Okay, so next, let's move to this Android location service. Okay, in the beginning, I did mention, okay, for Android, they have this service, okay, new Android location service. So here, as you can see, this is an example, Android emergency location service. So actually, we have this function, the Android user have this function in the device. Okay, they will access, actually they can access to our location of the device with high speed. That means they can track the location of our device faster. Okay, new Android location service. Same with this one, Android earthquake alert system. So for this one, Android earthquake alert system, this is not only the application of the location service. Okay, you need to implement what do we call this, sensor. Okay, sensor, I think you know what is sensor. Sensor is a device that you use to detect something. So they combine the device, the sensor, and then that's what we call as IoT, Internet of Things. Okay, so you need to have this sensor and then the access to your location. Okay, actually in Sabah, I'm not sure the exact location, but in Sabah, we do have this system. Okay, they will give like a warning, if I'm not mistaken, a warning, which is sounds when our sensor detector detect some warning. Okay, they will access the location, and then they will use the sensor. That's the IoT. Okay, so location best practice. First is remove location update. Okay, the update for you. Remove the location update. Second is set timeout. Timeout is your inactive session. Yeah, set the timeout. How long? This one is for security purpose. You set how long is the inactive session. And then batch request. Batch request, that means you can send, okay, we can send multiple requests in one call. And then passive location update. So this is the location best practice. Okay, so let's go to the first one first. Yeah, let's go to the first one first, which is location update. Okay, so remember we have 6 to 7 life cycle for mobile application process. So, okay, remove location update. So here on start, the first example here, this is the phase, on start phase and on resume phase. Okay, so the function is called request location update. Okay, request for location update, and then pause or stop is we hold the process or hold the update for a moment. Okay, so call remove location update. So we have the first one, to start or to pause, to run or to stop the location update. Okay, so this is the first. So again, you cannot understand this description here if you do not know what's the phase in here. We have 6 or 7, okay, for this phase. Remove location update. Next is set timeout. Set timeout, like I said just now, is inactive session. Okay, so method here, this is a function. Set expiration duration. Next is set expiration time. Okay, so there's a different. Duration is the period, how long, and then time is the time. Okay, so the duration, the time in MS since the method was last call. Okay, like I said, a period since last call, how long it is, and then set expiration time. Expiration time in MS since the system last boot. Okay, last boot. Next is batch request. Batch request, I already explained. We can send for a request, more than one request in one call. Okay, so here, first point here under the batch request, batch multiple requests together. We send multiple requests in one call. Okay, so suitable for non-foreground use case. So example, location is computed every 10 minutes. Okay, location is computed. They only receive the update on the location every 10 minutes. So here location request, set interval 10 by 60 by 1000. This one is the conversion, like I said, it is in MS. Okay, so if you want to set in 10 minutes, you need to do your own conversion in your code. So here is the set interval, and the next is set maximum waiting time. Okay. So this is the example to compute every 10 minutes. That means you will only receive your update, your location after 10 minutes. If I'm not mistaken, in WhatsApp, we have this one function which is share location. Okay, share location is not a real-time location. If I'm not mistaken, you can share within 8 hours, 8 hours or 15 minutes. They have the time there in WhatsApp. So you can share your location. It is not a real time. Why it is not a real time? They only update your, for example, 15 minutes. I choose for 15 minutes. They only update the location after 1 minute or 2 minutes. They have gap. That's why I said it is not a real time. Real time, that means they update you. Google Map West, that's a real time. For WhatsApp just now, they have the gap. That means it is not a real time. So they have this function. Okay, it's not 10 minutes for WhatsApp. I'm not sure, but yeah, it's not a real time. That means they only update your location after certain period of time. So the last one here, the last practice here is passive location update. Okay, passive location update is we get data from another app, obtain location data from another foreground app. So for example, location is compute every 15 minutes. Okay, this now is 10 minutes. So here they update to 15 minutes. So set interval. So this one is the conversion because it is in MS. So request set fastest interval, 2 by 60. Passive location update, and this is the example. So this is the last point for location best practice. Okay, so up to this page, is there any question? If no, please.
No.
Okay, so thanks, Noel. So can we have a break? I think around 10 minutes. So we will continue at 5:41 p.m. Okay, so see you after 10 minutes. Thank you. So hi, can we continue? Okay, so just now we already stopped at this, thank you, location best practice. So let's continue from this last non-location. Okay, so as you can see, last non-location here is equivalent to current location. Okay, so we have this basic setup in our device or our application, Google Play Service, which is the SDK manager. So I think I've explained the function of Google Play Service. So Google Play Service is used to ensure the security and then the reliability of our app. Okay, and then we have SDK manager here. So SDK manager is like a tool that allow the user to allow us view, install, and update. And then next setup is library. Library is where you keep, you save, or you store anything that related or you want to use for your project. Okay, so we have two basic setup here. Okay, so Google Play Service. Okay, this is your device and this is the Google Play Service. So in your device, of course, this is your app inside your device. Okay, so for your app, you have this Google Play Service library. And then you have this API client. So I don't think I should explain what is API again. You know what is API, what's the function of API. So for this API, okay, it is connected or you have this function, this service in our device. Okay, like I said, device for Android device. So they have this Google Play service. Okay, so here's the example. Okay, location service. Location service is, for example, the mapping function, your location. And then here, same map service, okay, the mapping and then other services, okay, other service that use the application. So this is the Google Play service. Okay, so next we are going to see the permission for manifest file. Okay, so for application, actually, even your application, you should have your manifest file because manifest file is we use to store the metadata for our application. So here we have, okay, permission, course, location. I think we have, can I skip? Yeah, I will fast forward to this page. Okay, we can see all of this permission here. So insert permission to manifest file. Okay, we have different type of permission. So the first one here is the course location. Okay, for course location, it will allow the app to access to approximate locations. Okay, so returns a location with accuracy approximately equivalent to a city block. Okay, accuracy approximately to a city, equivalent to a city block. And then find location, precise. Okay, find location is a precise location. And then the background is for Android 10 API and above. Okay, so as you can see here, the difference between this course location and then the find location. Course location is not as accurate as this one, find location. For find location, it will send you as accurate as possible. Okay, allow an app to access precise location. So this is the different type of permission. So permission, we have two different Android here. Android 6, this one is Marshmallow if I'm not mistaken. For Android 6 or higher. Okay, manifest file, because we need to include in manifest file. Same with this Android 10 or higher. So use permission. Okay, use permission, Android name, Android permission, access course location. Access course location. So let's see, course location. It will return accuracy approximately equivalent to a city block. Okay, that means they should return to you, to the user, to the app, based on this accuracy, not exact position. Same with this one. This one is access course location and then the background location. Okay, you need to state which type of permission or what permission that you want to request and what result you expect to receive. Next, if type of location permission. Okay, foreground location and then the background location. I will go to this page. So here we have foreground location and then background location. Okay, so there's a difference here actually. So first, share location. I think, yeah, we go to this table first before we go to the explanation. So share location. Share location. For foreground location, it's only once. That means within the within the period that we already set, okay, once. But for background location, it is constant. The visibility, it is visible for this one and then not visible for the background location because it's running at the background. And then persistent notification, okay, you will get a notification for foreground location, yes. For background location, no. So let's look at the first one, foreground location. So example, within a navigation app, a feature allows a user to get turn-by-turn direction. Okay, turn-by-turn direction. And then within a messaging app, a feature allows user to share their current location with another user. Messaging app. Messaging app is like the one I mentioned just now, WhatsApp. Okay, turn-by-turn direction. WhatsApp just now. WhatsApp is not a real time. However, you can know the location of your partner, other user, other user that share their location with you. It's not a real time because they have a gap. They have like an interval between the time. It's not a real time. I'm not sure how long, or I don't think minute. I think, yeah, I think within minute they will update within minute. Okay, so they will allow the user to get turn-by-turn direction, and then it allow the user to share their current location with another user. Next is background location. Okay, so background location, for example, within a family location sharing app, feature allow user to continuously share location with family. Continuously share the location with the family member. So within this app, IoT features allow user to configure their home device, such as they turn off when the user leave their home and turn back on when the user return home. Okay, within time. What's the example for this one? IoT. Turn off when the user leave. Maybe the smart home. Yeah, IoT. Smart home. For example, smart home. When the user, it will turn off the electric when the user leave, and then it will automatically turn on the electric once the user returns home. Okay, so this one is the background location. Next is how to declare the foreground location. So it is recommended to declare foreground service type of location. So here I have a comment here. Okay, required for Android 10 service. Android name, this is your apps, and then this is your service. You want to declare foreground service type. This means you opt for this type. Okay, and then this is the location. Foreground location. Next is Google Play service. Okay, so we have this on, yeah. So foreground location, it is recommended to declare a foreground. Do you have this one? Sorry, next is Google Play service, your app. So we have this method to create the instance of Google API client. Okay, on create is this one. Okay, to create an instance of the Google instance class of the Google. Next is communicate with Google service. How to link, how to link your app with the Google service. How to start the communication with Google service. Here is my, okay, let's go to this one first. Okay, Fuse location client. Okay, Fuse location client is a class actually. Yeah, it is a class. So under this class, they have this function. Actually, this code is not complete. So this one here is a completed one. I think you can see. Okay, on create function. Okay, so fuse location, fuse location client here is a class. So this is the on create function. Okay, so this function or this purpose is actually to know the last location. Okay, got last non-location to get the last location. From your lecture original code, I don't think you can see the use of this on start method, on create method here. Okay, so this is communication between your Google service. So question, among the three locations, find cause and background. Which one is suitable for mapping app and weather app? And then why it is necessary to start location request in on start method. So in which activity lifecycle method that you should turn off the location service? Lifecycle method, activity lifecycle method is this one, on start, on stop, and resume, on pause. Okay, so this one, okay, I will assign as usual. I will assign okay. So the first one, a mapping app. Which one is suitable for the permission? Rachel. And then next is weather app, Jeremiah. The second question, why it is necessary to start a location request in this method, Noel. And the last one is in which activity life cycle you should turn off the location service. For this one, the last question here, I think there's one patch just now I did mention and the answer is there. Okay, so this one I give you around 5 minutes to do. So I expect answer around 6:03 p.m. Okay, so we already received the answer here. So the first one, find cause of background. We have two apps here, mapping and weather app. The first one here, yes, it is find location. Why find? Because it is an accurate, okay? It is an accurate location. Second, oh sorry, for B, yes, it is correct course location, because for course location, it won't give you the accurate location. That means it is less accurate. For find, it is accurate location, but focus, it is not an accurate location. That means it's like in the area that they cover. For example, where the app, maybe for example, Sepangar, they have no accurate location. However, it is within that area. So second, why is it necessary to start location request in on start method? So this is the second life cycle actually. The first one here, sorry, the first one in our life cycle is, I mean the activity life cycle is on CRED. On start is the second one, so that the application can function normally. What do you mean by function normally, Noel? Can you type your answer in here, or you want to turn on your mic? And then number three, what do you mean by application can function normally? And then number three, which activity life cycle you should turn off the location service? The answer is in the previous slide. I don't remember, but yes, the answer is on pause and on stop. Okay, on pause and on stop. So they will like halt or stop the location service here. So for the number two, why is it necessary to start location request? What do you mean by so that the application can function normally? Mm. Actually, your answer is correct. Of course, so that yeah, actually your answer is correct. Wait, actually your answer is correct to function normally, but it is too general, so that the app can use location function, so that the app can access. Yeah, I think yeah, your answer makes sense. Function normally by accessing the location function. Okay, this question is too general and your answer is too general too. But then here your explanation, yes, so that the app can use the location service. Okay, so yeah, basically that's the answer. But again, the question is too general. So this is this part of question. So we have 10 more slides to go. Okay, next is location strategies. Okay, so we have challenge in determine the user location. Yes, of course, like I said, you can get the accurate location, but not the exact location. Okay, even for accuracy and just one more term. Is this not the same? Accurate and one more time I forgot. Okay, so it is a challenge in determining the user location. Why? Because multitude of location sources. Okay, multitude of location sources to get the data, to get the location, and then the user and then the user movement. User movement here is like I said is now, okay? The apps, the WhatsApp app, they won't give you a real time. However, they still have a gap in delay. Yeah, they have delay in return to you the result because of the movement and then varying accuracy. Okay, so here is the location update. Location update, a flow chart. So we have start connect to location service. Okay, connect to location service is the on start function just now in the life cycle. And then we send, sorry, it's send for a request. Send for a request. So of course you have this yes or no. So if yes, they will update the UI. Of course, they have different interface. And then if no, what they will do is, okay, if no, they will pause or not. Okay, it's like looping in here. If no, they will pause. If yes, they will continue. If no, they will keep on looping. Okay, so if it is paused, you have two options, yes or no. If yes, then they will stop the location update. Okay, so it's like this is actually look complicated, but this is only in two flow. It is either yes or no. That's it. Okay, so this is the logic of the location update, logic of the flow. So this is the screenshot of how your application or how the application asks for permission. Request location access during the runtime. So as you can see here, share location while using the app. I think this one is updated version of Android. So allow app X to access this device location. So using the app, while using the app, that means you can run concurrent application in the same time. So send my current location. Okay, so this is the screenshot. Next is the permission. Version higher use enable background location on a setting patch. Yeah, like I said, I think this one is the latest higher version. So here Android 11, higher version, use the enable background location on a setting patch. So yeah, this is the setting patch. So mock location data. Mock location data is like a testing. Okay, mock is like a testing. So use mock location data for testing purpose. Okay, it's like dummy data. So provide mock location data by inject the GPS location data. GPS is the global positioning system just now. Okay, so using DDMS to set location to your FVD, your file, and then geocoding. So this is the term geocoding, geographic location to an address. That means we want to convert geographically coded. It's not geographically coded. It's like we mix this term geographic and then the coding. Okay, that's what we call as geocoding. So we have this possible issue error, no location data provided, no data at all, and then invalid latitude or longitude use. This one, latitude and longitude, is the location. Okay, the location, and then no geocoder available. Geocoder is another. Not all programmer can do this geocoding. That's why I stated here, no geocoder available. When you do programming, doesn't mean you know how to do this geocoding. And then no address found. Because you need to know how to read this thing, latitude and longitude. I cannot do this. So here is the last part. So here is the review question. For this one, you may try on your own. So we have, I think, 3 patch. Yeah, 3 patch, 6 question. So I let this part for you to try. We will discuss this one in our next class, the review question. So we have 6 question in here. 6 or 5? 6 question. Okay, please try to do this 6 question. No, I know you won't do. So I will assign the first one, Ian. Second is Wong Z Heng. The third one, Celine. Number 4, Catherine. Simon. Daniel. I think everyone already. So this one I will be by me. Okay, so 6 question. Please do the question and we will discuss later in our next class, which is next week. So this is the conclusion to this chapter. Chapter 5. Explain what is the LBS, location-based service. And then understand and explain the key concept of Google Play Service Location API. So this is the last part. of our class for today. So for chapter 5, before we dismiss, is there any question? No, please raise your hand. Okay, so I received no question. Oh, before we stop, I have a reminder for you. First for Noel and Kelvin. Yeah, please check your Google Classroom for your FYP. There's a new announcement there regarding your FYP, only for Noel and Kelvin. Okay, that one is the first. Second is, I think yesterday I did share with you guys invitation to a talk this Saturday. So please come to the talk. Okay, it will be by a speaker, Mr. Jeff Head. Okay, Mr. Jeff Head is the twin brother to Mr. Jeff, our lecturer. So please come and listen to the talk. Okay, so if no more question, I think we can. Oh, no wonder. Yes, Noel, Mr. Jafter is the twin brother. Okay, so if no more question, I think we can dismiss. So see you next week and thank you everyone. Bye-bye.